Hi students, today we discuss paper 2 multiple choice chemistry IGCSE code 0620 and the paper code is 22 and the series is October-November 2024. It is the MCQ paper. Okay, let's start. Question number 1. Oxygen melt at minus 219 degrees centigrade and boil at minus 183 degrees centigrade. At which temperature is oxygen is liquid? So the best suitable temperature in which oxygen is liquid is minus 189 degrees centigrade. If you remember the properties of oxygen. Question number 2. The pressure of a sample of gas is decreased. The temperature is kept constant. Which two describe the effect of the particle? Movement of particle, collision between particles. So if you remember the collision theory, when we decrease the pressure, there is no change in the speed of the particles. And the temperature is kept constant. So there is no change in the speed of the particle and the collision between particles occur less often. So the best option is C. Next. Rubidium has two isotopes, rubidium 8537 and 8737. Which statement explains why both isotope has the same chemical properties? So if you remember the properties of isotope elements, so the best suitable option is they have the same number of protons, they have the same electronic configuration, they have different number of neutrons, they have different mass number. So both of them have same electronic configuration. So the best suitable option is B. Next. Question number 4. Which pair of elements react to form a compound with a strong attraction between oppositely charged ions? Carbon and bromine, carbon and nitrogen, sodium and oxygen, sodium and potassium. So we have to see the strong attraction between oppositely charged ions. So the oppositely charged ions are sodium and oxygen. Question number 5. For substances P, Q, R and S are described. P is diatomic, Q is a good conductor of electricity when solid and when molten, R is a silver solid with a very high melting point, S react with oxygen to form brown gas. Which substance are metal? So remember the properties of metal. Q is a good conductor of electricity when solid and when molten. R is a silver solid with a very high melting point. So the option is C. Next question. Which diagram shows the covalent bonding in molecule of carbon dioxide? Simple, very easy. This one. Option number C. The bonding structure and melting point of sodium chloride and sulfur dichloride are shown. Compound. Sodium chloride, ionic bonding, giant lattice structure and its melting point is 801. High melting point. Sulfur dichloride, covalent bonding, simple molecular structure and its melting point is minus 121, too low. Why does sulfur dichloride has a lower melting point than sodium chloride? The covalent bond in sulfur dichloride are weaker than the attractive forces between molecules in sodium chloride? No. The covalent bond in sulfur dichloride are weaker than the ionic bond in sodium chloride? No. So, the attractive forces between molecules in sulfur dichloride are weaker than the attractive forces between molecules in sodium chloride? This one is also not a good option. The attractive forces between molecules in sulfur dichloride are weaker than the ionic bonds in sodium chloride? Yes. The attractive forces between molecules in sulfur dichloride are weaker because it has a simple molecular structure as compared to sodium chloride. It has a giant lattice structure. So the attractive forces are weaker than the ionic bond in sodium chloride. Yes. Question number 8. Diamond and graphite have giant covalent structure of carbon atom. Which statement describes graphite? It has a strong rigid three-dimensional structure. It has 4 strong covalent bond between each carbon atom. It has layers which can slide over each other. Yes, the best suitable answer is option C. As you remember The graphite, if you remember its structure, it is like that, it has layers. Question number 9. Which will explain the malleability and electrical conductivity of a solid metal? Malleability and electrical conductivity. In uh, malleability, rows of positive ion can slide over each other, so they can be easily malleable. Electrical conductivity, delocalized electron can move freely through the structure. So the best option is C. Okay. The equation for the decomposition of ammonium carbonate. Decomposition of ammonium carbonate is shown. Ammonium carbonate, it decomposes into ammonia, carbon dioxide, and water. Liquid form में water. And ammonia and carbon dioxide are in gaseous state. The total volume of gas produced is 360 centimeter cube at RTP. Which mass of ammonium carbonate is decomposed? So now we have to do some working for this question. So first we found out the number of moles of gas. Number of moles of gas is equal to volume of gas divided by total volume. Volume of gas is 360 degree centigrade, centimeter cube, and the total is 24,000 at room temperature and pressure. The total volume is the volume of 1 mole of gas at room temperature and pressure, and which is constant, and its value is 24,000. Okay. Point 015 moles. So the mole of gas are 0.015 moles. Now we found out the moles of okay. From equation we see that 1 mole of ammonium carbonate produces 2 mole of ammonia gas, 1 mole of carbon dioxide gas, and water liquid form. So 1 mole of ammonium carbonate produces 3 mole of gas in total. 1 mole of ammonium carbonate produces 3 moles of gases. इसमें ammonia plus carbon dioxide. Okay. Now we have to find out the moles of ammonium carbonate. Divided by 3. The volume of the moles of gas, moles of ammonium carbonate is equal to moles of gas divided by moles of gas is produced. So the answer is 0.005. So 0.005 moles of ammonium carbonate are used. So now we have to find out the mass of ammonium carbonate, which is decomposed. So write down the formula of mole, number of mole is equal to mass over molar mass. So rearrange this formula. Mass is equal to moles multiply molar mass. Now put down the values. 0.005 multiply, and molar mass is 96. So the answer is 0.48 gram. So its option is B. Okay, next question. What is the empirical formula for compounds that contain 3.66 gram of hydrogen, 37.8 gram of phosphorus, and 58.5 gram of oxygen? Now the main formula for first we write down the elements: hydrogen, phosphorus, and then oxygen. Now for hydrogen. Its molar mass is equal to 1.01 gram per mole. Moles of hydrogen, 3.66 gram. So it is 3.66 divided by 1.01, and the answer is 3.62, approximately equal to 3. And for phosphorus, molar mass is equal to 30.97. You can take the molar mass from the periodic table at the end of the question paper. Moles of phosphorus, 37.8. So 37.8 divided by 30.97, it is about 1.22, approximately equal to 1. Oxygen. For oxygen, molar mass 2618, moles 58.5, 58.5 divided by 16 is equal to 3.66, approximately equal to 3. So we have HPO, it is 3, 1, 3, 3 ratio 1 ratio 3. So the formula is H3PO3. The best option is C. Okay, next question. Aqueous copper 2 sulfate is electrolyzed using graphite electrode, which will identify the product and observation at each electrode during the electrolysis. Graphite electrodes are used anode, cathode. At anode product is oxygen, bubble of gas, and at cathode product is copper. Electrode turns pink. Look at the next options. Product copper, electrode turns pink, oxygen, bubble of gas. Now, C none, electrode dissolve, copper, electrode turns pink. Oxygen, bubble of gas, and electrode dissolve, hydrogen, bubble of gas. So the best suitable option is A. At cathode, at anode, oxygen will be bubble off, and at cathode, product is copper, and the electrode turns pink. If we look at the rest of the options, copper will not be at anode. It will always be at cathode, and oxygen is always bubble off at anode. Okay, next question. Question number 13. Molten sodium chloride is electrolyzed using inert electrodes. Which row shows the product formed at the cathode and anode? If you remember the electrolysis of sodium chloride, anode, cathode, sodium is at cathode, and chlorine is at anode. Anode has positive charge and cathode has negative charge. So chlorine will be at anode and sodium will be equivalent at cathode. So the best option is D. At cathode, sodium, and at anode, chlorine. The equation for the formation of ammonia is shown. Nitrogen plus hydrogen to ammonia. The reaction pathway diagram for the reaction is activation energy. This is the activation energy plus 250 kilojoule per mole. Enthalpy change, downward arrow, and the total energy released is minus 342 kilojoule. And ammonia is formed. Now, what is the enthalpy change for the reaction? So write down the formula for enthalpy change. delta H is equal to total energy plus activation energy. Total energy is minus 342 kilojoule per mole. Activation energy is plus 250 kilojoule per mole. Now minus 342 plus 250 is equal to minus 92 kilojoule, and the option is B. Okay, next question. Question number 15. Sulfur dioxide is converted to sulfur trioxide in the contact process. Okay, now we have to remember the contact process. The condition used are 450 degrees centigrade at 200 kilopascal with a vanadium V oxide catalyst. Which row describe and explain the effect of changing condition on the rate of reaction? Change in condition, effect on rate, explanation. No catalyst, effect on rate lower, the activation energy is higher. Higher pressure, effect on rate higher, the particle have more kinetic energy. Low temperature, lower, the particle collide more frequently. Lower pressure, higher, there are more particles per unit volume. Changing condition. So in changing condition, there is no catalyst. Effect on rate is also lower. The activation energy is higher. So the best suitable option is option A. The question: which row describe and explain the effect of changing conditions on the rate of reaction? If we remove the catalyst, the reaction will be slow, rate of reaction will be lower, and the activation energy will be high. If we change the pressure, high pressure, the effect on rate is higher, the particle have more kinetic energy. No. This is the not suitable option. We can change the pressure, but it has no effect on the rate. Low temperature, effect of the rate. Low temperature also has no effect on the rate. The particle collide more frequently. No, at low temperature, the particles will not collide more frequently. They are slow. Low pressure, effect of rate higher. There are more particles per unit volume. No, this is also not suitable. So the best option is A. Hydrogen gas react with iodine gas to form hydrogen iodide gas in an equilibrium reaction. Hydrogen plus iodine to hydrogen iodide. Enthalpy change is plus 26.5 kJ per mole. Which changes increase the yield of hydrogen iodide at equilibrium? Adding a catalyst, adding more hydrogen gas, increasing the pressure, increasing the temperature. So when we add more hydrogen gas and increase the temperature, the yield is increases. The yield of hydrogen iodide is increases because hydrogen gas is needed for the equilibrium reaction. When the reaction is carried on, the hydrogen iodide forms, and if we add more hydrogen, the reaction will not be stopped. So the option is D. Adding more hydrogen gas and increasing the temperature. Question number 17. The equation for the reaction of carbon and carbon dioxide is shown. Carbon plus carbon dioxide, carbon monoxide is formed. Which to identify the carbon atom that is reduced and its change in oxidation number. Atom that is reduced, carbon in carbon dioxide and oxidation state. This one, +4 to +2, because it is changed into carbon monoxide. Option is B. Question number 18. Aqueous iron 2 sulfate is added to acidified potassium manganate. The purple color of potassium manganate disappears. Aqueous potassium iodide is added to acidified potassium dichromate, a dark brown solution form. Which to identify the role of iron 2 sulfate and the potassium dichromate in these reactions? Iron 2 sulfate is a reducing agent and potassium dichromate is an oxidizing agent. So option is D. Which row shows the difference between a weak acid and a strong acid? A weak acid is partially dissociated and a strong acid is fully dissociated. Option is D. If we look at the rest of three options, number A is fully dissociated and partially dissociated. Weak acid is always partially dissociated and strong acids are fully dissociated. Weak acids are concentrated. No, weak acids are not concentrated. Strong acid are dilute. Strong acid may not be dilute. These are strong or may be dilute or may be concentrated. Weak acids are also may be dilute or may be concentrated because we have to change their concentration by adding more water or the solvent. Which substance turns methyl orange red? Dilute hydrochloric acid. If you remember titration, so the end point is red color. Which row describes zinc oxide and calcium oxide? Zinc oxide is amphoteric and calcium oxide is basic. Okay, I hope you can understand this. We will continue that past paper in our next video. Stay tuned with me.